Okay, so we are familiar with the problem. We know what we need to do, and let's go ahead and get started. So we've already answered these three questions. So the first thing we're going to do is we want to compute and then simplify the average velocity from zero point 0.5 to zero point 0.5 plus h. Now this is going to be abstract because we really don't know what h is. H is a variable here. So I'm going to take s of 0.5 plus h minus s of 0.5 over 0.5 plus h minus 0.5, which we have already seen before. We've talked about that this is just going to reduce to h because 0.5 minus 0.5 is 0. So I just have h in the denominator. Now, let's start with s of 0.5 plus h. Let's just start with this part right up here. And if I use my my s of t formula that they gave me, which was 16 minus 16t squared, then wherever I have a t, I'm going to replace that with 0.5 plus h. So this is 16 minus 16 times 0.5 plus h squared. Of course, I have to handle the square before I distribute the negative 16. So I'm going to go ahead and square 0.5 plus h, which gives me this. Now I can go ahead and distribute the negative 16 through. So negative 16 times 0.25 is negative 4, minus 16h, minus 16h squared. Do a little bit more simplifying. I get 12 minus 16h minus 16h squared. Okay. Now, if we put that back into the original computation, remember that was just this part of it. So now what I have is my 12 minus 16h minus 16h squared minus, now I got to take s of 0.5. So it's, remember the function was 16 minus 16t squared. So it's going to be 16 minus 16 times 0.5 squared. Notice this negative sign and this negative sign here, and I'm subtracting this entire quantity. This is just going to be some value, which we're going to figure out in a second. So now that gives me 12 minus 16h minus 16h squared minus 12. That's what this value works out to be, 12. I have my h in the denominator, which we know where that has now come from. And so this simplifies to negative 16h minus 16h squared over h. And that's looking pretty good right now. But there's a little bit more we can do with this. We can actually, well, let me go back here and say, we see that the average velocity, because this is what this is, the average velocity from 0.5 to 0.5 plus h clearly depends on what that h value is. We also know that h cannot equal 0. Remember that. So, and we talked about that. So this denominator of 0 right now is a problem because h cannot equal 0. So what we're going to do is we are going to factor out the h. And so when I factor out the h, that leaves me in the numerator negative 16 minus 16h over h. These h's now reduce. I get negative 16 minus 16h, and that's going to be the expression for the average velocity from 0.5 seconds to 0.5 plus h seconds. Remember, here's 0.5 seconds, here's 0.5 plus h, but h has some restrictions. I don't, those restrictions are between negative 0.5 and 0.5. Okay, so this is actually going to make our life a little bit easier, believe it or not, because we can use this expression now to calculate the average velocity on any interval from 0.5 to 0.5 plus h. So let's say we have from 0.5 to 0.75, right? Instead of using my average velocity formula, I can now just use negative 16 minus 16h, but I got to figure out what h is. So if I start at 0.5 here, and I go to 0.75 here, what is that h value? Well, that h value is now 0.25. So all I have to do is plug 0.25 in for h. I simplify this thing, and I get the average velocity from 0.5 to 0.75 is negative 20 feet per second. So it took us a little bit of work to get to this formula here, but in the end, it's going to save us some time. Now, here's where h can be negative. If I want to compute the average velocity from 0.4 to 0.5, think about this now. Here's 0.5, and here's 0.5 plus h, but now I'm going 0.4 to 0.5. So 0.4 is over here. So h is going to be a negative 0.1. Does that make sense? Hopefully it does. If it doesn't, you can ask me a question about it. So now when I plug in negative 0.1, when I plug in negative 0.1 for h, that's going to go away in a second. Then I get negative 16 minus 16 times negative 0.1, which gives me negative 14.4 feet per second. And we know that the negative is a good thing. We've talked about this, that means the ball is falling. We expected to get a negative average velocity because we knew in the example that they talked about a ball falling with this. Okay, now what happens as the average velocity? What happens to the average velocity as h gets closer and closer to 0? So here's 0.5, here's 0.5 plus h. We're going to get it closer and closer and closer. We want that gap to be infinitely small. So we want that h value to be 0 or as close to 0 as we can get. Well, look at what happens here. What happens as h gets closer and closer to 0? What's going on with this value right here? Can you figure that out? So what happens is this 16h becomes incredibly small. So small that we don't even care about it anymore. And so we can say the instantaneous velocity at t equals 0.5, it's our conjecture right now, that as h gets really, really close to 0, that the instantaneous velocity at 0.5 is going to be negative 16 feet per second. And that's how these problems work.